So when you're out there on your standardized test, I'd like you to keep your eyes out for cancellation. Cancellation can make a really hard-looking math problem much easier. We'll start with a real simple example. Suppose they ask, what is the product of these fractions? 1/2 times 2/3, all the way up to 7/8. I know many of you are thinking, can't I just type it in my calculator? And you could, but there's a faster way. If you remember that a number on the bottom cancels with a number on the top, because multiplying and dividing are opposite operations, you can go ahead and cross all these out. And when you've done that, you can see you're left with just a 1 on top and an 8 on the bottom, and there's your answer, 1/8, faster than any calculator. Okay, let's see if we can spot some cancellation in this next problem. If S represents the sum of the first 30 positive integers and T represents the sum of the first 32 positive integers, what is T minus S? You might start this question by trying to write out what T and S look like to get a feeling for what's going on. Positive integers all the way up to 30, 31, 32 for T. And for S, 1 plus 2 plus 3 added up all the way out to 30. Now they ask you to find T minus S. So we're going to subtract row 1 minus row 2. See, the shortcut here is we're not going to take all the time to all the way add up 1 through 32. We notice that 1 minus 1 is 0, 2 minus 2 is 0, 3 minus 3 is 0. In other words, all these cancel out up through 30. What am I left with? Two numbers left over at the end, 31 plus 32. Their sum is 63, and there's your answer. All the other values just canceled out. Hi, let's take a look at one more. The sum of a list of n consecutive integers is 0. If the smallest integer on the list is -10, what is the value of n? The key here is to first understand what they're asking you. Basically, they want to know how many numbers are on the list, and you're adding up not just any numbers, but consecutive integers, meaning they're in a row. So we could start writing it out as -10 plus -9 plus -8 plus, at some point we'll get to 0, and then we'll start adding some positive numbers. How far do we need to go so that the sum of all of them equals 0? The key here, of course, again, is to look for some cancellation. If you extend the list to positive 10, you'll notice that -10 plus 10 cancel to 0. -9 plus 9, again 0. -8 plus 8, 0. And all the numbers, positive and negative, will be paired up so that the sum of all of them simply equals 0, which was our desired sum. Finally, we could go ahead and count up how many numbers are on the list. You'll see that there's 10 negative numbers ending at -1. There's 10 positive numbers ending at 10. And then don't forget about one number right here, 0. And you'll see that there's 21 integers in all on the list.